Every year, 40,000 construction workers suffer these like really severe hand injuries on the job.
Yeah, the numbers are just staggering.
Right. And for decades, the industry's default solution to this has just been simple. You just hand out thicker, heavier gloves.
Exactly. Just bulk up the PPE and hope for the best.
But we have reached a breaking point where that strategy is, well, it's actually making the problem worse, not better.
Oh, 100%.
So today on this deep dive for the Scaling Legends audience, we are looking at an emerging technology that is actively cutting a $960 million industry problem entirely in half.
Which is, frankly, something the industry desperately needs right now.
Yeah. If you are a construction business owner, a general contractor, or, anyone responsible for running a crew, you're in the right place today.
And we're not just talking about theory here. This is about moving past this outdated idea that smashed fingers and lacerations are just an inevitable cost of doing business.
Right. Like it's just part of the job.
Exactly. We are looking at a fundamental shift in how job site safety operates, and it's being driven by some really incredible recent deployments.
Okay, let's unpack this.
Right.
Because to set the stage for you, we have breaking news out of the UK. A construction safety forum just successfully deployed an AI-driven hand injury prevention system on live active job sites.
And that's key. It wasn't a lab.
Right. This wasn't a lab test with controlled variables. This was muddy, chaotic, real-world construction.
The real deal.
The software was developed by a company called 3E, and it was so effective at predicting and stopping injuries before the stem was even broken that it just won a major safety innovation award.
Which is a massive deal when you understand the sheer financial and human scale of this issue. I mean, hand injuries currently sit as a top 3 construction injury category in the U.S.
Right, behind falls and struck-like incidents, right?
Exactly. And that 40,000 number you mentioned earlier,
Yep.
that represents roughly 110 severe hand injuries happening every single day.
Man, it's basically a packed baseball stadium of workers getting hurt every single year.
It really is.
And if you run a crew, these aren't just like statistics on the spreadsheet. A severe hand injury can end a master carpenter's career in a split second.
It's just gone. Decades of experience over in a millisecond.
But let's look at the financial weight of that too, because the numbers are staggering.
They really are. The average direct and indirect cost of a single recordable hand injury on a job site is $24,000.
Wow, 24 grand for one incident.
Yeah. So when you do the math on 40,000 injuries at 24 grand a pop, the construction industry is bleeding nearly $1 billion.
Yeah.
960 million to be precise every single year.
That is just an astronomical amount of money.
And that includes the immediate medical bills and workers' comp claims, sure. But it also includes the lost time, the massive disruption of hiring replacement labor.
OSHA fines.
Oh, definitely the OSHA fines.
Yeah.
Plus the work stoppages that just ripple across the entire project schedule when a recordable incident happens.
But here's the thing that always gets me. We know they cost a fortune. We know they're devastating to the worker, and literally everyone out there is wearing modern safety gear.
Right.
So why are these incidents so stubbornly common?
Well, it comes down to the dynamic, highly unpredictable nature of the work itself.
Yeah.
I mean, you are rarely dealing with a static environment on a job site.
Things are constantly moving.
Exactly. The most common culprits we see are nail gun misuse, pinch points during heavy material handling, inexperienced workers misjudging distances, and sudden power tool rotation.
Like when a heavy-duty drill binds up.
Yeah, exactly. Like when it hits a knot in the wood and violently kicks back.
Yeah.
But the underlying variable across almost all of these is just sheer fatigue.
Meaning the worker just gets tired and makes a sloppy mistake.
It's actually more biological than that. When a framer has been, say, running a nail gun or holding a grinder for 9 hours, the constant vibration actually causes micro trauma to the capillaries and nerves in their hands.
Wait, really? Just from the vibration?
Yeah. Their baseline grip strength weakens significantly, and their neurological reaction time physically slows down. They might consciously feel okay, but their hands literally cannot react fast enough.
Wow.
And that delayed millisecond is exactly when a glove gets caught in a spinning grinder, or a finger gets pinched between 2 steel I-beams.
And the traditional response from safety managers to those pinch points and lacerations has just been to mandate, level 5 cut resistance and heavy impact rubber on the knuckles.
Right, the thicker gloves.
But I have to push back on that mindset. Giving a carpenter incredibly thick gloves to prevent cuts is, well, it's like wearing winter snow gloves to type on a smartphone.
Oh, that's a great way to put it.
You completely lose your tactile dexterity. You can't feel the threading of a bolt. You can't feel the exact tension on the trigger of the nail gun.
Yep, you're just fumbling around.
So you get frustrated, you take the glove off to do the fine detail work, and bam, that is exactly when the accident happens. The supposed solution actually causes the hazard.
That is a perfect analogy. And if we connect this to the bigger picture, it highlights the fundamental limitation of passive physical barriers.
Right.
Yeah.
Standard personal protective equipment, no matter how advanced the Kevlar weave is strictly passive. It only helps you the millisecond an accident is already taking place.
It's reactionary.
Exactly. It mitigates the damage, hopefully keeping you from losing the finger entirely, but it does absolutely nothing to prevent the event from happening in the first place. The industry has effectively reached the absolute limit of what passive PPE can accomplish.
So to actually move the needle on a billion-dollar problem, we have to stop reacting and start predicting. We need an intervention system that knows you are about to crush your hand before you actually do it.
Precisely.
Which brings us back to what 3E just pulled off in the UK and this whole concept of construction AI hand injury prevention. But here's where it gets really interesting. I need to understand the mechanics here.
Okay, sure.
If traditional gloves aren't enough, how exactly does artificial intelligence stop a spinning drill from catching a worker's hand?
It does it by shifting from passive protection to active prevention, using a triad of new hardware and software. Think of it as like a digital guardian angel.
Okay, I like that.
The first pillar of this tech relies on computer vision cameras. Now, we need to be clear here. These aren't standard security feeds sending video to a server for a safety manager to review next week. These use what is called edge computing.
Wait, edge computing meaning the camera processes the video right there inside the device itself instead of, sending it up to the cloud.
Exactly, because if a saw blade is spinning at 3,000 RPMs, you literally cannot afford the 2-second latency of pinging a cloud server.
Yeah, 2 seconds is an eternity with the power tool.
Right. So the AI chip is built directly into the camera. It visually identifies human skeletal structures in real time.
Right.
It maps the exact spatial relationship between a worker's hand and a known hazard.
So it knows where the danger is.
Yes. So if it sees a hand entering a predictive danger zone, say moving toward the unguarded side of a table saw, the system registers that anomaly instantly.
I get the cameras, but a camera can only see what is happening on the outside. It can't see the nerve fatigue inside a worker's arm that you mentioned earlier, right?
Very true.
If the worker's grip is failing because they've been using a chipping hammer for 4 hours, the camera just sees a guy holding a tool right up until he drops it.
Yeah.
There's a biological blind spot there.
Which is exactly why the second and third pillars are wearable tech. The second pillar is the smart glove itself. This is the absolute cutting edge of smart glove construction safety tech.
So what makes it smart?
Well, to the worker, it looks, flexes, and feels like a standard high-dexterity work glove. But woven into the fabric are these microsensors that constantly detect grip force, vibration levels, and hand orientation.
Wait, so it's actively measuring the vibration of the tool while they use it?
It is. If a worker is holding that chipping hammer, the glove measures the exact hertz of the vibration.
That's wild.
Yeah, and if that exposure exceeds safe biological limits, indicating the worker's nerves are fatigued and they're about to lose their grip strength, the glove registers the danger before the worker even consciously realizes their hand is going numb.
Unbelievable. And what is the third piece of the triad?
Wrist wearables. Think of like an industrial-grade smartwatch. These track repetitive motion and monitor for broader fatigue patterns.
What kind of patterns?
They're looking for microtremors in the forearm or a specific slowing of movement that indicates the worker is physically exhausted overall.
But hardware alone just gives you a mountain of raw data. A superintendent doesn't have time to read a spreadsheet on microtremors while pouring concrete. This is where 3E's software comes in, right?
Precisely. And that synthesis is exactly why 3E won the Safety Innovation Award.
Yeah.
Their software acts as the central nervous system connecting all these isolated sensors.
Bringing it all together.
Right. It doesn't just passively record data for a post-mortem report. It aggressively analyzes it in real time to identify unsafe compounding patterns.
So it's looking for combinations of risk.
Exactly. If the computer vision sees a hand drifting too close to a pinch point, or the wrist wearable detects severe grip fatigue, 3E's software pushes an immediate physical vibrating alert to the worker's wrist to stop them in their tracks.
So the worker gets a physical tap on the wrist to wake up and step back. What about management? Are they in the loop?
Simultaneously, the system sends an alert to the site supervisor's tablet. But even more importantly, it automatically generates a near-miss report and feeds that data directly into the company's safety KPI dashboard.
Oh, wow.
Yeah, it completely automates the reporting of leading indicators, which has historically been, the hardest data for a safety team to collect.
Okay, so 3E has this incredible award-winning system, but they aren't the only ones playing in this sandbox. A live construction site is messy, it's loud, and there are a lot of different trades operating at once.
Very true.
I want to look at the broader ecosystem here, because according to Smart Business Automator's Market Intelligence Report, there are currently 23 construction safety AI vendors active in the field right now. Who are the other key players contractors should be watching?
The market is specializing rapidly, which is actually great for contractors with specific needs. Beyond 3E, you have companies like Kenzen.
What's their focus?
They focus heavily on the physiological side, so heat stress and ergonomic wearables. Their sensors monitor core body temperature and micro movements to predict and prevent heat stroke and severe muscle sprains.
Very cool. Who else?
Then you have the Slate Safety Band, which also monitors heat, but incorporates advanced slip and fall detection.
What about the smart glove and camera-specific side, since we were just talking about that?
In the smart glove sector, ProGlove is making massive waves. They originally built their tech for complex manufacturing and logistics, but they are successfully bridging over to prefab construction shops, where dexterity and tracking are critical.
Got it. And the cameras?
On the computer vision side, Intenseye is a major player. They don't require proprietary cameras. They plug their AI right into a site's existing security camera network to analyze behavioral safety.
Oh, that makes deployment way easier.
Exactly. And SmartVid.io is fantastic for overall job site analytics, pulling visual data to predict risk levels across an entire multi-year project.
But here is my concern. I guarantee this is what every superintendent listening is thinking right now. Alert fatigue.
Yes. The classic problem.
Right. If I am running a massive commercial build with 200 guys on site, does my phone just buzz 500 times a day because someone moved their hand weirdly or picked up a hammer? Because if my phone becomes a spam machine, I am throwing it in the nearest porta-john.
That is the most common and frankly the most valid fear from field leadership.
Yeah.
If a system cries wolf, it gets ignored.
Exactly. It becomes background noise.
But the advanced AI in these systems is specifically trained using complex anomaly detection. It filters out the noise. It doesn't alert you based on a single, isolated data point. It looks for high-risk compounding patterns.
Give me an example of a compounding pattern. What does that actually look like?
Sure. So the system will not alert you just because a worker turns on an angle grinder.
Yeah.
That is normal work.
Right.
But it will alert you if the worker using that grinder has been operating it for 3 hours straight. Their wearable indicates their grip strength has dropped by 40%. Andy, the edge computing camera, sees their hand positioning slowly shifting away from the handle and toward the blade guard.
Okay, that makes sense.
The AI synthesizes those 3 separate data points to say, hey, this specific worker is in imminent danger of a laceration. It delivers actionable insights, not just a constant stream of minor infractions.
That completely changes the value proposition. It is looking for the perfect storm, not just a cloudy day.
That's a great way to put it.
And I imagine for this to actually work, this data cannot just live in a vacuum on some separate app. It has to connect to the software these contractors are already using to run their jobs, right?
Seamless integration is entirely mandatory. These platforms are designed to talk directly to the tools contractors already rely on.
Like Procore.
Yes. For instance, the data from these wearables and cameras connects directly into Procore, specifically through the Procore Safety AI integrations, as well as Autodesk Construction Cloud.
So it's all in one place.
Exactly. So while the field supervisor gets those immediate smartphone alerts for imminent danger, the executives back in the office get beautifully synthesized weekly management summary reports.
So it upgrades the weekly safety toolbox meetings too.
Oh, absolutely. Instead of the foreman giving a generic mandated talk about ladder safety because it's Tuesday, they can say, hey guys, the system showed a 20% increase in pinch point near misses on the steel framing yesterday afternoon. Let's huddle up and adjust our material handling approach right now.
It makes safety proactive instead of reactive.
Precisely.
So what does this all mean for the bottom line? Let's talk about the economics, because the technology sounds incredibly futuristic. But at the end of the day, Contractors live and die by the budget, the schedule, and their margins. A system like this has to justify its cost.
It definitely does.
Let's run the actual math on the return on investment here.
The math is where this transition goes from being a nice-to-have sci-fi gadget to an absolute business necessity. Let's look at an average mid-sized general contractor with 50 field workers.
Okay, 50 guys.
Statistically, a GC of that size is going to see 3 to 5 recordable hand injuries per year. Now, implementing a robust AI wearable and camera system across that crew costs between $400 and $800 per worker per year.
Okay, so for a 50-man crew, you are looking at a maximum annual investment of around $40,000.
Right.
40 grand out of pocket before a single wall is framed. That is not pocket change for a mid-sized GC.
No, it's not. But remember, the baseline cost of a single hand injury we discussed earlier.
The $24,000.
Exactly. If this technology creates even a conservative 40% reduction in incidents, that saves that GC 1 to 2 recordable injuries a year. Preventing just 2 injuries saves $48,000.
Wow.
Yeah, the system literally pays for itself in under 12 months just in direct injury prevention.
And that is only calculating the direct medical and work stoppage costs of the injury itself. What about the regulatory side? I mean, the insurance premiums have to factor in here somewhere.
Well, the insurance side is the hidden multiplier. When you have fewer recordables, you obviously maintain a lower, cleaner OSHA inspection profile. You also lower your DART rate days away, restricted or transferred.
Right.
But the real massive financial win is the construction workers' comp EMR improvement.
The experience modification rate.
Exactly. Your EMR dictates your insurance premiums. A typical contractor implementing this level of predictive tech sees an EMR improvement of 0.05 to 0.10 by year 2.
Which is huge.
It's massive. If you have a large payroll, dropping your EMR from a 1.0 down to a 0.90 saves tens, sometimes hundreds of thousands of dollars in insurance premiums alone. And because your costs are lower, it makes you drastically more competitive when you are bidding on new jobs.
The financial case is undeniable. The math completely works. But I am going to throw a massive wrench into this because there is a human element we haven't really touched on yet. The workers out in the field.
Okay, let's hear it.
I have been around enough crews to know they are going to hate this. Nobody, and I mean nobody, wants a Big Brother sensor strapped to their wrist, tracking their every micro movement, measuring how tired they are, and reporting them to the boss.
Yeah, that's a very common pushback.
If you force this on a framing crew, guys are going to actively try to trick the sensors, or they'll just accidentally forget them in the porta-john. How do you possibly get past that massive privacy friction?
It is a totally valid concern, but what's fascinating here is that the assumption that workers will universally reject it doesn't actually hold up if the rollout is managed correctly. Yeah. Smart Business Automator's market intelligence report shows a 72% worker acceptance rate when the wearable is explicitly positioned as worker protection and the data documentation is entirely transparent.
Wait, 72% acceptance right out of the gate. That is way higher than I would have guessed for a wearable tracker.
It all comes down to the psychology of framing and job site culture. If management rolls this out as a surveillance tool to catch people being lazy or cutting corners, it will fail overnight. You will get exactly the sabotage you just described.
Makes sense.
But if it is framed correctly as a digital shield designed purely to make sure they go home to their kids with all 10 fingers intact, the psychology shifts entirely.
But how do you actually prove that to them? Words are cheap on a job site.
You prove it with radical transparency. You show them exactly what the dashboard sees. You prove that the data isn't being used to dock their pay or penalize them for taking a breather.
So you share the screen, basically.
Exactly. You show them it is being used to tell the foreman, hey, the sensor says John's grinder is vibrating 20% more than usual today. Let's swath the bearing before it kicks back and breaks his wrist.
Oh, okay.
When workers realize the tech is genuinely there to protect their bodies and extend their careers, the buy-in happens rapidly.
That makes total sense. It is the difference between a tool that manages you and a tool that protects you.
Precisely.
So knowing the undeniable ROI math and knowing the psychology required to get the crews to actually wear the gear, how does a listener pilot this on a job site next week without bringing their operations to a grinding halt?
You need a highly specific, controlled rollout. We call it the 90-day playbook. The biggest mistake you can make is deploying this company-wide on day one.
Oh, that would be chaos.
Total chaos.
Yeah.
Step 1, pick one single pilot trade to start. I highly recommend framing, structural steel, or electrical.
Why those three specifically?
because they are highly hand-intensive trades with massive repetition, high tool vibration, and high pinch point risk. You'll get the clearest data fastest. And crucially, pilot it with volunteer workers first.
Don't force it.
Right. Find your veteran crew leaders who already champion safety and ask them to test drive it. Get your internal champions on board before you mandate anything.
Okay, so you have your volunteer crew. What is step 2?
Step 2 is getting vendor demos of at least 3 different systems to see what fits your specific job site culture and tech stack. Bring in Kenzen to look at the biometric side. Bring in Intenside to see how their computer vision integrates with your cameras.
Evaluate one of the UK-style AI vendors like 3E too.
Exactly. Let your pilot crew handle the hardware. Are the gloves comfortable? Are the wristbands bulky? Let them look at the software dashboards.
And once they pick the vendor they like, how do you actually measure if the tech is doing its job during the pilot?
That brings us to step 3, which is critical. You deploy the sensors to 10 workers for a 30-day blind baseline period.
Blind meaning the alerts are turned off.
Exactly. You do not turn on the buzzing wristbands or the supervisor alerts yet. You just let the system quietly monitor in the background to see the true current state of your job site.
Oh, that's smart.
You need to know how many near misses are actually happening every day that nobody's reporting.
Yeah.
You need that baseline. Once you have 30 days of raw data, you transition into a 30-day intervention period where the real-time alerts are finally activated.
So you are directly comparing the blind baseline to the active alerts.
That is step 4, and it is purely data-driven. You measure the exact reduction in near-miss and recordable hand injuries between those 2 30-day windows.
And then you decide.
Right. You only scale the technology across the entire company if the ROI confirms the math. If the near misses drop by 40% during the intervention period, you roll it out to everyone with confidence. If the numbers don't move, you pivot to a different vendor.
It's a low-risk, high-reward pilot structure that completely removes all the guesswork.
Exactly.
It is a brilliant approach. You are taking a massive, chaotic, billion-dollar industry problem, and you are shrinking it down to a 10-man, 90-day math equation that literally any GC can run.
And I will leave you with this forward-looking question to think about as this tech matures. If an AI wearable can reliably predict and prevent a $24,000 hand injury before the skin is even broken, how long until the insurance companies simply refuse to underwrite contractors who aren't using smart gloves?
Man.
The data is becoming far too clear for actuaries to ignore. In 5 years, these wearables might be as mandatory on a job site as a hard hat and steel-toe boots.
It's not a matter of if, it's strictly a matter of when. If you know a contractor who is dealing with high workers' comp premiums or trying to keep their crews safe from hand injuries, send them this deep dive. It could literally save them tens of thousands of dollars and keep their best workers on the job. Hit follow on whatever app you're listening on so you don't miss tomorrow's intel. And be sure to visit smartbusinessautomator.com.